Good morning, everybody. It is Tuesday, April 21st, and we are going to go over the second day of negative exponents in section 823. So to begin with, we're going to review what the point is of scientific notation. And basically, we're using scientific notation to be able to write easily and compare easily really large and tiny numbers. So if we look at this number right here and this number right here, we don't see the commas in there that kind of help us understand where the place values are. And I even wrote these in different size fonts, so it's harder to tell which one's larger as well. But if we put in the decimal point after one digit, and then we figure out how many place values there are after that, it's really easy to write it in scientific notation and be able to compare those numbers. So if we look at this, if we start with the decimal point after the 3, we have to move our decimal point over 3, 4, 5, 6, 7, 8, 9, 10, 11 places to the right. Direction is significant. So I would write 3.46 times 10 to the 11th because I'm going from 3.46 and moving to the right 11 places. If I look at this problem, I would start off with 7, one digit in front of the decimal. I would put my decimal point here, and then I would count how many places I'm going to have to move the decimal over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I count how many places the decimal is going to move over. It doesn't matter whether there are digits in there or whether it's a 0 that kind of holds that place value. We write 7.85456. We don't have to put the string of zeros after that, times 10 to the 13th, because when I put my decimal right here, the decimal needs to move over 13 places to equal our original number. When we write it in scientific notation, it's really easy to see this one is going to move over 11 places in our place value. This one's going to move over 13 places. Obviously, this is the larger number. The same thing happens when we do very tiny numbers. So we start off with this number. We look for what's called our significant digits, and that's what shows right here, the 4, 5, and the 6. So I'm going to take my first significant digit and put a decimal right here. And then I'm going to count how many places do I want to move that decimal place over to the left. We go 1, 2, 3, 4, 5, 6, 7, 8 places to the left. So I'm going to write 4.56 times 10 to the negative 8 because now I'm moving it to the left. When I wrote the 4.56, in order for it to be worth this value here, the decimal needs to move over 8 places to the left. Do the same thing with this number. Here we have our significant digits show up at the 5. So we put our decimal one digit after the 5. And we count how many places do I need to move that decimal over to the left so that it'll be worth this number. And we get 1, 2, 3, 4, 5, 6 places to the left. So I write 5.468766156 times 10. Because I'm moving it to the left, it's 10 to the negative 6th. Okay. Sometimes we'll have numbers and we have to decide if it's in scientific notation or not. And if it's not in scientific notation, we need to rewrite it. This one is not in scientific notation because the decimal is not after one digit. This first number, when we write it in scientific notation, always has to be greater than or equal to 1 or less than 10. That's why we always have just one digit in front of the decimal. So I'm going to take this, and instead of 0.648, I'm going to write 6.48. Make that look like a decimal and not a 0. But I have to be careful because this number was multiplied by 10 to the 7th. If I take my 648 and the decimal was way in the front, I need to move it over 7 places. So this is what that number was intended to be worth. Well, I've changed it. I put the decimal place in here. So I don't want to move it over 7 places anymore. I only want to move it over 1, 2, 3, 4, 5, 6 places. So when you're rewriting in scientific notation, be careful that you're adjusting that power of 10 also. If we look at the second problem, we have 56.8. Once again, this is not scientific notation because we have too many digits in front of the decimal point. So I'm going to take those significant digits that I have, 5, 6, 8, and I want to put the decimal in right here. So I'm going to write 5.68. However, when the decimal was here, they were multiplying it by 10 to the negative 4th. That would move our decimal place over 4 places to the left. That's what this number represents that they originally wrote. Because we adjusted it and we put the decimal point right here, we don't want to move it over 4 places. We only want to move it over 1, 2, 3 places now. So we need to say times 10 to the negative 3rd. Okay, be careful that you're adjusting that power of 10 just like you are adjusting the decimal for our first number. Now, not all the problems we're dealing with are with scientific notation. So we're going to practice simplifying this. If I have 8 to the 7th power, I can write that as 8 times 8 times 8 times 8 times 8 times 8 times 8. We have 7 factors of 8. Now, I want to multiply it by 8 to the negative 11th. That means that I need to take the 8 to the negative 11th and put those 11 factors of 8 in the denominator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Cancel out your giant ones. Okay, we still have a factor of 1 in the numerator. All these 1 times 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 1, that remains as a factor of 1 in our numerator. We have 4 factors of 8 in the denominator. So I can write this with positive exponents by writing 1 over 8 to the 4th. I could also write it with negative exponents because if I'm dividing by 8 4 times, that's the same thing as writing 8 to the negative 4th. We'll repeat that process again. So we have 7 to the 7th power. So I'll do 7 times 7, 7 times. 1, 2, 3, 4, 5, 6, 7. And then we're going to divide that by 7 times 7 because it was 7 to the negative 2. So we will cancel out our giant 1 factors. And now we have 5 factors of 7. The order makes a big difference. We're multiplying 7 by itself 5 times. Now, in this case, it's not appropriate to rewrite it with a negative exponent because it's already positive exponents. So we're just not going to do that. And now our last one, we're going to start with y to the 5th. So we'll multiply y by itself 5 times. 1, 2, 3, 4, 5. And then we're going to divide that by, we'll divide that by y multiplied by itself 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Cancel out our giant ones. We still have that factor of 1 in the numerator. So I'm going to put 1 over y times y times y times y is y to the 4th power. If we want to write it with negative exponents, 1 over y to the 4th, we're dividing by y 4 times, so we write y to the negative 4th. Go ahead and open up the Google Doc and practice those same 3 types of problems. If you have questions, make sure you're logging into conference hours every Monday through Friday at 10 a.m.